Welcome to the CMSC Virtual Poster Tour. This poster is titled Quantification of Smooth Pursuit Dysfunction in Multiple Sclerosis. I'd like to introduce the presenter, Dr. Jennifer Graves. Dr. Graves is Associate Professor of Neurosciences and Director of Neuroimmunology Research at the University of California, San Diego. Welcome, Dr. Graves.
Thank you, and thank you for this opportunity to talk about our work.
What is smooth pursuit dysfunction, and what is the underlying cause of this visual abnormality in people with MS?
There are two basic ways that humans and animals track visual targets. One is through a smooth ocular motor movement to track the visual target. The other are faster eye movements called psychotic eye movements. Both can be abnormal in MS patients, but the smooth pursuit aspect has not been studied as extensively in terms of quantitative assessment. Damage in MS can affect multiple parts of the brain that contribute to smooth pursuit function. Some of these areas include the movement-sensitive part of the visual cortex, V5, the frontal eye field, supplemental eye fields. Some studies have implicated the basal ganglia, the cuneus, as well as brainstem and cerebellar dysfunction. So any of these structures can be impacted by MS and contribute to a breakdown in the ability to smoothly track a visual target.
Can this manifestation occur in conjunction with other visual abnormalities, or is it seen on its own?
So there are many different types of visual dysfunction in MS. We largely group them into afferent and efferent dysfunction, afferent being more along the lines of optic neuritis and losing the ability to transmit signal effectively from the retina to the brain. And we have efferent dysfunction, which tends to generally refer to disorders of eye movement. So smooth pursuits fall more in the category of efferent visual dysfunction.
Interesting. And does this dysfunction occur in other neurological diseases as well?
Yes. So we can see breakdown in smooth pursuit performance in a number of neurologic conditions, including encephalopathies, brain trauma, concussion, some dementias. So it's not specific to MS, but we hope by studying the specific features and quantifying what happens in MS patients, we will find some distinctive aspects of this breakdown in multiple sclerosis.
Please give me a brief review of how your study was conducted.
We performed a pilot study applying a technology, NeuroFit, that had been originally set up in the Ames NASA laboratory to test the pursuit function of Navy pilots. It's also been used to study the performance in baseball players and those with high performance needs in terms of visual pursuit tracking. And we decided to apply this technology in a pilot study for MS patients and some locally recruited controls. They were placed on a chin rest, and we had a monitor set up 16 inches in front of them. There was a built-in program that provided a high contrast visual target for them to target through different areas of their visual field with different speeds and direction changes to track the performance of their visual pursuit mechanisms. We repeated the test a couple of times, 3 times in each patient, so we could look at reproducibility as well as try to come up with the most accurate mean value for their performance in these measures. And then we compared the MS patient's performance both to a large reference control group that the company had recruited previously, as well as to our local controls. And the main findings were that the MS patients, on average, for all the different metrics that we collected, as well as a composite metric of smooth pursuit performance, did less well than the large reference population and also compared to our local control groups. But on average, all of the point estimates suggested a poor performance in MS, but it also strengthened our confidence that we can quantify these abnormalities. For example, an MS patient trying to track smoothly a visual target will often have what we call psychotic interruptions. It'll look a little choppy. Instead of smoothly arcing through space, the eyes will have to insert some jerky corrective saccades to get back to the target. And about 35% of the time in an MS patient, you have to use these psychotic corrections, compared to the healthy population only had to do this about 20 to 25% of the time.
Were you able to determine whether there were any particular MS symptoms that occurred in people who had the smooth pursuit dysfunction? For example, could it be dizziness, difficulty reading?
So excellent questions. We know that efferent visual dysfunction, oculomotor dysfunction contributes to those symptoms. It wasn't a primary focus of this study to link the quantitative measures directly to those clinical symptoms. In fact, we had several MS patients who were clinically asymptomatic but still had evidence of dysfunction.
You mentioned the potential for this measure as a biomarker in MS. Tell us a bit more about that.
In multiple sclerosis, we have a largely unmet need to develop more quantitative measures that allow us over short time intervals and with high sensitivity and reproducibility to assess the amount of damage to the brain that a patient may have from their disease. Like we've done in the afferent visual system with optical coherence tomography, we have the opportunity to leverage the efferent visual system to create another biomarker that can look at subclinical or slowly progressive damage over time by tracking the smooth pursuit function. It's amenable to quantification. If we develop the right approach, it could be highly reproducible, non-dependent on the rater performing the test, and be able to track either subclinical or subtle changes in dysfunction in certain brain structures by using this eye tracking technology. We could also look for the ability to improve this damage, either through remyelination, repair, or neuroprotection approaches, and be able to use this approach in clinical trials. There's a lot of work to do to be able to make it a standard outcome measure, but I think it holds a lot of promise as a way to be another quantifiable, possibly highly sensitive readout of injury from MS.
That's really interesting. Thank you so much for joining us today.
Thank you so much for having us and for allowing us to share this work. We also want to thank our patients who gave their time for us to be able to do this study, and all of my colleagues who worked together to collect this pilot data. Thank you again.